More interesting patterns. Last time we have seen triangular numbers, numbers between two square numbers. Now let us start with adding odd numbers. Add numbers in order are 1, 3, 5, 7, 9, 11. If we add two odd numbers, that is 1 plus 3, which is 4, and that is 2 square. Then if we add three odd numbers, that is 1 plus 3 plus 5, this is 9, which is 3 square. 1 plus 3 plus 5 plus 7 is 16, that is 4 square, and so on. So if we add odd numbers, then we get that sum as square of some natural number. So one method of finding square root is consider a perfect square and go on subtracting consecutive odd numbers from it. 25 minus 1 is 24. 24 minus 3 is 21. 21 minus 5 is 16. 16 minus 7 is 9. And 9 minus 9 is 0. Now we get difference 0 in fifth step. Therefore square root of 25 is 5. This is one method to find out square root of a given number. Fourth pattern, sum of consecutive natural numbers. This is also for odd numbers. Which are the odd numbers? 3, 5, 7, 9, 11 and so on. 3 square is 9, and that can be expressed as sum of two consecutive natural numbers. How to obtain those numbers? It is 3 square minus 1 upon 2 and 3 square minus 1 plus 1 upon 2. 3 square is 9, 9 minus 1 is 8, 8 upon 2 is 4. 9 plus 1 is 10, 10 upon 5, 10 upon 2 is 5. This is 25. 5 square 25 minus 1 upon 2, it is 24 upon 2, that is 12, and 5 square plus 1 upon 2, that is 26 upon 2, which is equal to 13. So square of odd numbers can be written as sum of two consecutive natural numbers. Now let us consider 7 square. 7 square is 49. Which are those two numbers? 7 square minus 1 upon 2 and 7 square plus 1 upon 2. 49 minus 1, 48. 48 upon 2 is 24, and this is 50 upon 2, because 49 plus 1 is 50. 50 upon 2 is 25, and so on. You can check this for remaining odd numbers. Product of two consecutive even or odd natural numbers is a perfect square. Product of consecutive even or odd natural numbers. 11 is odd and its next odd number is 13. We can write this in terms of their middle number, that is 12 minus 1 into 12 plus 1. This is in the form of a plus b into a minus b, that is 12 square minus 1 square, that is 144 minus 1, that is 143. So 11 into 13, which is equal to 143. So that can be written as 11 into 13 is 12 square minus 1. Now let us consider another pair of such numbers. Let us consider 15 and 17. That is in terms of the middle number. It is 16 minus 1. 16 minus 1 is 15 into 16 plus 1. So this product is 16 square minus 1 square, which is actually 1. So this is 256 minus 1, that is 255. So if we find out 15 into 17, the answer will be 255. And you can check it for another pair of consecutive odd numbers. Some more patterns in square numbers. Here we observe the number is formed by only single digit, that is 1. Here we have 1, so that is 1. So 1 square is 1. 11 square, there are 2 times 1. So we write it as 1, 2 and 1. Here we have 3 times 1. 1, 2, 3, 2, 1. So we have to go on increasing number up to the number of ones. Here number of ones are 4. So we will write 1, 2, 3, 4. Now decrease the numbers 3, 2, 1. We can check it with the help of calculator. 1, 1, 1, 1 square. 1, 2, 3, 4. 3, 2, 1. Here we have 1 5 times. So the square is 1, 2, 3, 4, 5. And now decrease the numbers 4, 3, 2, 1 and similarly. Another interesting pattern. 7 square is 49. 67 square is 4489. 667 square is 444889. So observe the pattern. Here we have 6 2 times, then 4 is 3 times, 8 is 2 times and 9 is once. Here we have 6 3 times, so 4 4 times, 8 3 times and 9 once. What will be the units place digit of a square of the following number? 81 square, its units place will be 1. You can solve this as last digit ends with 2, square will end with 4. We have asked to solve unit place digit only. Don't find the perfect squares because some numbers are very big. So find out just the last digit. Following numbers are obviously not perfect square given the reason. A perfect square cannot end with 2 or 3 or 7 or 8, and these numbers, observe the end digits of the given numbers. The square of which of the following would be odd number? Square of odd number is odd. So the number which is odd, its square is also odd. Here we have to observe the pattern. 1 2 1. Now this is 101. So 1 0 2 0 1. Here we have 2 zeros. So 1 0 0 2 0 0 1. How many zeros are there? 4 zeros. So 1 2 3 4, then 2, then 1 2 3 4. 1 2 3 4 5 6. So it is 1 0 0 0 0 0 2 0 0 0 0 0 6 times 1. Observe the following pattern and supply the missing number. Here number of ones is 2, number of ones is 3. So this is 1 0 2 0 4, then let us observe the pattern carefully. 2 zeros, 1 1. The end ones are there. Then we have to increase the number up to the number of ones. So here there are 4. So the middle term must be 4. Then 1 0, 2 0, 3 0, 4, and now opposite 0 3 0 2 0 1. Let us check this. One zero 1 0 1 0 1 square, 1 0 2 0 3 0 4 0 3 0 2 0 1. Now the highest number is 5, so this is 5 times 1. 3 4 5. So this number square is 1 0 2 0 3 0 4 0 5 0 4 0 3 0 2 0 1. Using the given pattern, find the missing numbers. 1 2 square 2 square, 1 2 3 4 5 6, 2 3 4 5 6, then 2, then 6, then 12, 2 to 6, 3 times. Okay, this is 2 ones are 2, 3 twos are 6, 4 threes are 12, 5 fours are 6 fives are 7, 6 are, and this is 3 square 7 square. This difference is 4, this difference is 6, this difference is 8, 10, 12. So this is 43 square. Try to solve the remaining questions. Finding the square of a given number. Now multiply the number with itself to obtain its square. Now if we want to find out square of 56, which is 56 into 56, or we can write this as 50 plus 6 whole square. As we have identity, a plus b whole square is a square plus 2ab plus b square. So a square means 50 square is 2500 plus 2 into 50 into 6 plus 6 square. So this is 2500 plus 600 plus 36. 2500 plus 636, and this is 3136. Other patterns in square. 25 square is 625, that is 2 into 3 into 100 plus 25. 35 square is 3 into 4 hundreds place. Okay, this is 25 square. Whenever a number ends with 5, its square ends with 25, and this 2 and its consecutive digit is 3. 2 into 3 is 6. 35 square, digit number ends with 5, so square ends with 25. 3 into its consecutive digit, that is 12. Pythagorean triplet. For a given triplet, if square of bigger number, here for 6, 8, 10, 10 is a bigger number, square is 100. And let us find out sum of squares of remaining two numbers. Therefore, what we can write, 6 square plus 8 square is equal to 10 square. Therefore, 6, 8 and 10 is a Pythagorean triplet. Find the squares of the number. Write a Pythagorean triplet whose one number is given. Okay, one member is 12. If one member is given, let us see how to find out remaining two numbers. If we take m square minus 1 is equal to 12, then we get m square is equal to 12 plus 1, that is equal to 13. Then the value of m will not be integer because 13 is not a perfect square. Now let us try m square plus 1 is equal to 12. So m square is equal to 11 will not give an integer value for m. Now let us consider 2m is equal to 12, so m is equal to 6. And m square plus 1 is 36 minus 1, and m square plus 1 is 36 plus 1, that is 37. So 12, 35 and 37 is a Pythagorean triplet. Now 6 is one number. Let us use the same method. Let us try, if we take m square minus 1 is equal to 6, then we get m square is equal to 7, which is not a perfect square. So let us consider m square plus 1 is equal to 6, that is m square is equal to 5, which is again not a perfect square. So let 2m is equal to 6, so m is equal to 3. Now find out m square minus 1 and m square plus 1. M square minus 1 is 3 square minus 1, that is 8, and 3 square plus 1, that is 10. So this 2m, then m square minus 1 and m square plus 1 is a Pythagorean triplet. Therefore 6, 8 and 10 is a Pythagorean triplet.